Will my experimental driveshaft work, or will it fail in a short time? It's a design I haven't seen before and it's taken me months to build. In this video I hope to find out, but first I have some surprising problems to solve which, if you're anything like me, you'll find interesting. I have discovered a couple problems. The first problem is I need a haircut. I can solve that one, not too worried about that one. The next one is not so easy. Now, from the last video I mentioned centrifugal forces on a design that Freezertron sent to me, and I was surprised at how big those centrifugal forces were. Now, I didn't do any centrifugal calculations on these roller guides and how they are attached to the tube because I thought it was insignificant, but it turns out it is significant. To my surprise, the force trying to pull this off of the tube is going to be 162 kilograms. I'll put my calculation up on the screen so you can check it. There's also an online calculator for centrifugal force, which is pretty handy. 162 kilograms then, trying to pull these 12 832 UNC bolts out of where they're threaded into this aluminium. Now the bolts will take that force, I'm quite certain. I haven't done that calculation yet. I will do, but I don't think it's going to be anywhere near of any concern. But what is concerning is the thread in this aluminium, that size UNC, is equivalent to around M4 in metric. So there are 12 of those holding this 162 kilograms on here. So I think I need to do a test. I need to put a bolt in a threaded bit of tube. I'm not going to use this one, obviously. And then I'm going to see how much force it takes to pull it out. Once I know how much force it takes to pull one bolt out, then I'll have a better idea of whether this 162 kilograms of force is going to be something I need to address. What it has done is brought to my attention the significance of the RPM of this shaft and how important it is for everything to be balanced and running true. I've just welded in these sleeves which take this rod, and I'm worried that what if this has caused enough distortion to bend this tube and now it's running far too way out. So that's a concern there. The next concern I've got is these roller guides I made, they vary in weight by 3 grams at the moment. Now that is not acceptable for rotating at this speed. I think 1 gram was about 1 kilogram of centrifugal force difference between one side to the other, which, that's clearly not going to work. So these have to be balanced within each other, I think, between about 0.1 of a gram. That's not going to be a problem. I can do that. That's all right. But I'm more concerned about getting this to run true enough at that speed to work. I would say chances of success of this type of shaft working is maybe 50-50, whereas when I started building this shaft I thought maybe 80 to 90% I thought it's going to work. So it has brought the speed of this shaft to my attention. This is the setup I've got here. I've got the same tube, it's the same grade, and the hole is drilled in the same place on the tube. It's 832 UNC, exactly the same, and that is the bolt we're trying to pull out of the aluminium, and we can measure it using this scale. So what do you think? What is your guess of how much force it's going to take to pull that out of the aluminium? Anything above 13.5 kilograms could potentially hold on to the roller guide. What I want to see is a lot more than that. Oh, anyone that guesses right, put it in the comments and I'll give you a free subscription. Look, anything moved? I think so. 53 kilograms. Let's go a bit more. Oh, 60, 58, 60. Oh, ooh, there we go. Is that 65? Well, I'm not quite sure what moved. I don't think it was a thread because we're still going at the moment. Up to 80, 84. 100. 10. And 20. And 30. And 40. Wow. And 50. And 60. I think my strap's going to let go. Yeah, it's a strap. My strap is breaking. I wouldn't have thought that. Amazing. I'm equipped with a better strap. Let's try that. Ooh. 160, 170. Wow. 200. This scale only goes up to 300. Good grief. Oh, I think that's close. That's close. I didn't. Well, I think that's it. I don't think that's going to fall off. Myself and my friend had a little debate. I guessed to how much force it will take. I guessed 30. He guessed 300. Perhaps I ought to listen to him more often. What I did was I put this in a milling machine and I milled off flats on each one because I left these long so that I could do that. That means that because I clocked this tube in, that each side is sticking out the same amount, providing the tube isn't bent. So far it doesn't look like it is, at least not significantly, so I'm going to proceed at the moment. I've cut the CF53 hardened rod, and that is a decent fit in 3 of them. One of it's, I think it's that one's a bit looser than the rest. Maybe I can do something to make it so it's not so easy to move. The pin length is 0.1 of a mil shorter than the gap between the 2 roller guides. I kept that as little as I could, and I've made these test rollers. The rollers are going to be phosphor bronze. I didn't want to muck up for phosphor bronze, so I just made them out of steel for now, so I can do a test assembly.
I don't think so. No, 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 no. I don't think so. No, 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 no. It's never, ever, 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 ever gonna happen. I don't think so. No, 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 no. I don't think so. No, 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 no. It's never, ever, 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 ever gonna happen. I don't think so. No, 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 no. Maybe someday you'll have it your way. Maybe someday it'll all work out.
With half of them on, it moves, but it's a bit bindy. It's going to take some time to find out where it's binding and solve these issues. I'm just slacking off the screws a little bit, and that's all it took to free it up. So it's not much, it's just finding what to do. I've got this assembled now, all apart from one, obviously. There's one that's tight, the rest are all slightly loose. And it's fairly free to run up and down like that. But I need to know whether the roller needs to come down in diameter or it needs to come down in length. I've just marked the inside of this guide, and hopefully that will leave a witness mark so I can make the alteration. Let's have a look then. I'd say there's a bit on the diameter. If you can see that there, a bit in there as well. I don't think I'm going to take the diameter on the pin down, because that's really not what I want. If there's too much slack on the pins, then you get play here. I've got to make that as little as possible so that the run out between this tube and this tube is as good as I can get. think a bit of sanding on this face and that face, and we'll see what that's like. I think what I'll do is I'll tighten all these bolts up, get it to lock up again, and then I'll put it in the lathe, spin it, clock this diameter in here, and measure the run out, because if this is too far out, I've got a bit of a problem to solve. There's no easy adjustment. If this is out, there's no easy adjustment. It all comes down to the precision of which I've made these guides, precision of what I put the slots, precision of how I've drilled the holes through here. There's a lot of variables that could cause this to run out too far. I'm not sure what too far out is going to be. I would imagine sort of 1/2 mil run out, probably too much. I can't work that out personally. So it's a bit nerve-wracking having spent all this time to find out whether it's going to work or it's not. I've got this the best I can, and that is because this tube is slightly oval now, probably due to the machining, and I'm clamping bolts to it as well. The divisions on the clock, so from 40 to 30 there is 0.1, 0.2, 0.3, 0.3, nearly 0.4 of run out. Well, it's not run out, it's ovality, maybe some run out as well, but I can't really get that any better. Let's see then what it's like on here. This should be fairly round. Moment of truth. What's it like? 0.1, 0.2, 0.3, 0.4, 0.4. Well, that ain't too bad. That ain't too bad. Phew. I can work with that. I think if I spin it up, that'll look quite good, I should imagine. Let's have a look at that.
I don't think so. No, 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 no. I don't think so. No, 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 no. It's never, ever, 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 ever gonna happen. I don't think so. No, 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 no. I don't think so. No, 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 no. It's never, ever, 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 ever.
I'm pretty pleased with that. It means that I don't think it's good enough as it is right now. It's too far out, but it's not miles out. I think I can do something to try and dial this in. You can sort of, in the order you tighten the screws may affect its position, and you may be able to move this slightly to affect its position, and when it's fully clamped, it's where it should be. There are other ways to improve this situation. Say I machined this tube. Say I made this tube and I clamped it in here somehow, and then I bored this tube so that it was concentric. You know, that would be a better way to get more accuracy. While I was talking to you, my old homemade waste oil burner was getting a bit hot. I think the kettle's boiled, and it's not even on the plate. Nice and warm though. Having tested the centrifugal forces on these screws from the weight of this, I thought I would see what the centrifugal force would be trying to make this roller contact the base of the slot. This only weighs 5.5 grams, what it will do in phosphor bronze, but that gives a centrifugal force of 6.3 kilograms pushing down like that. And when you've got 8 of those, that's quite a lot. The force, the rotating, the twisting force, so pushing in this direction against the slot side, at maximum engine power will be 28 kilograms. So 28 kilograms that way, 6.3 kilograms that way at full RPM. The question is, will the 28 kilograms take precedent over the 6.3 and stop it binding up? Or will there be a problem? That is the next concern, and I'm not sure. I think perhaps under load it will be okay, but if you reduce the load, so you took off the rotor RPM, took off the power, it could start to bind up. Or it might just bind and there's nothing I can do. Problems. With this new information, I'm wondering how the old drive shaft actually worked. This is a CV joint off an Audi A4. It's a tripod CV joint. And I wondered what the weight of these rollers were. And it's 88 grams. And at this radius, that will produce a force of 75 kilograms pushing out that way. Now, how this is different is there is a rounded groove for this rounded bearing to slide up and down in. And as you twist, it's going to want to centralize this bearing so that there's no rubbing. There needs to be a bit of clearance between this edge and that edge, otherwise the bearing won't rotate. In the Audi A4 that it was designed for, you wouldn't exceed this CV joint going faster than 1500 RPM. That would be the top speed of the car. And the maximum torque would be somewhere around 2000 pounds-feet of torque. Now you can see as the speed reduces and the torque increases, there's not going to be any problem with this bearing pushing out and causing too much friction. But when I put it in the helicopter, it's now running 3 times faster, 5500 RPM, and the torque is down to about 55. And with that centrifugal force, that 88 gram roller becomes 75 kilograms that way, as I said, and there's only going to be 50 kilograms of force in that direction, keeping the bearing centralized. So you might think then that because the centrifugal force is greater than the force going that way, it would bind, but it didn't. There was no problem with control forces whatsoever using this joint, which is interesting. This is another tripod CV joint. This is a reproduction joint, whereas that one's genuine Audi. This is reproduction. And they've done it slightly different, and there's no sort of radius groove that's like a full radius. This has got like a half radius, and these bearings are radius to suit. These are free to float as well. But in this case, you might have more friction if I use this joint, because it's there's more surface contact, I believe, with this type of joint. Should I run it at that really high speed, generating that high centrifugal force? You can imagine there's quite a lot of design that goes into this sort of joint. As we articulate this, we can see that the rollers are moving in and out, which of course they need to facilitate the articulation of the joint. And we can just about detect some free play, which I said there needs to be free play. Keeping that to a minimum is important for me. Looking back at mine again, there's no radius to kind of push this bearing away from the face. But let's say I did have this radius. Let's say I tapered this edge this way, so that when it pushed in this direction, it would also push in this direction. That may be a way to solve it. I'm not sure if it will work, but it might do. Another solution, which was suggested by Freezertron, was to have this end capped off with a radius, so that any kind of friction here would be reduced to a point. That might work. It's definitely an option to try. What I'm going to do is I'm going to just make them like they are, make them out of phosphor bronze, and see if it's an issue. After sanding the guide faces smooth and parallel using slip gauges to measure the slot width, I've got to cut the UNC screws to length. To make sure they all come out the same, I've made this cutting guide and I'm deburring them on the belt sander. If you make sure you deburr the thread in line with the direction of the thread, you won't have any issues screwing them into anything. If you sand across the thread, it will push another burr into the thread, and you will need to screw on a die to clear that too. I've milled this hexagon on here to apply torque to the assembly. Applying near maximum engine torque, I can barely move the sliding shaft. This is worrying.
Swapping the steel rollers for needle rollers, the test is much more positive.
Although the friction is lower using these needle rollers, I don't really want to use them. As I explained in the last video, they're designed to be pressed into a 12mm hole, and they measure about 12.05 millimeters, and that is the press fit. And when it's pressed in, it has a really nice fit on this precision ground hardened shaft. But as it is at the moment, when it's not being pushed into a hole, there's a little bit of play. And I don't want that play, and that's one of the reasons I'd rather not use them. The problem is, will phosphor bronze bushes be low friction enough for this to work? I need to measure the rolling resistance under load with this bearing and then a phosphor bronze bearing, and then I'll do the steel ones as a comparison as well. I've got this set up here to test the friction. The weight here is 50 kilograms, which is virtually the same as what full power would be loading on the bearings, and it's very easy to move with these needle rollers. It's not even worth trying to set that up really, because it moves so easily. There's no concern there at all. I've changed the rollers for the steel ones now, and the friction is massive, and actually the whole rod is turning. There's no wonder that didn't work. I made some phosphor bronze bushes and there's still too much friction. The whole shaft is turning as it did with the steel ones. So that means phosphor bronze cannot be used, and I have to use these needle rollers.
Well, I was hoping to get to the stage of running this shaft under engine power in this video, but having to carry out some testing of parts has put me behind. That's the trouble sometimes. You have to spend the time that only gives you answers and no actual parts are produced. Setting deadlines doing this type of work is a bit pointless, and I should know better. You can't foresee what issues might arise and what direction you end up going in. The video is already very long, so let's end it there, and I hope that next time I get to do an engine run-up.